Hello mathematicians, we're going to have a look at some more equations of lines, and in fact probably the one that you will go to most often, and that is the point gradient formula for a line. Not so much because it's the way to write a formula, but it's the way to derive a formula. So if we know, for example, the gradient of a line, so we're told the gradient, and we know one point that it passes through, then if I just drew the line up, marked a point, and just imagine some other point on the line, then we know that the gradient formula says m is y2 minus y1 over x2 minus x1. So for some other point on the line, whatever it is, so it's some generalized point on the line, then we're going to have that the gradient is going to be just y minus y1 over x minus x1. Rearrange that, of course, and we get this, which, as I said, is going to be your go-to equation for working out lines, or the formula of lines. So let's have a look at going to it. Using our point gradient formula, find the equation of the line through this point and with a gradient of 3, and rearrange into general form, which is the other name for standard form. Then we'll have y minus y1, which is 5, equals m outside of x minus x1. So y minus 5 equals 3x minus 9, error point number 1, not multiplying the brackets out correctly. Put it into general form, so we need the x coefficient to be positive, so this y will have to come across, that 5 will have to come across and be added, and that's our equation. Again, this is another point, or another part, where the amount of space devoted to this is not indicative of the importance of the concept. So 3 lines are concurrent, means they all pass through the same point. And this can be tested by solving 2 lines simultaneously. So we know that the process of finding where 2 lines intersect can be done by solving them simultaneously, and then testing this point in the equation of the third line. It's also possible, but we wouldn't do it, to prove that 3 lines are concurrent by solving all 3 equations simultaneously. But we've seen what a trial that process is. So if we just solve 2 of them simultaneously, and then we get the coordinates of that point, if it then satisfies, that point satisfies the third line, which means we substitute it in and it makes the equation true, then that third line also passes through that point. So take a little bit of time to get your head around the logic of this, not to memorize it, but to understand the concept and then add that to your arsenal of understanding. So let's have a go at this question. So part 1 says find the point M of the intersection of these 2 lines. So we write those down. This becomes equation 1. This is equation 2. This is a pretty stock standard solve by elimination. So if we take 1 and 2 and add those, that will give us 5x. The y's disappear. This will be 15. So x is 3. Take that 3 and put it into either equation, so I'll stick it into 1. So 3 plus y equals 2, y equals 2 minus 3, which is minus 1. So we know that these 2 lines cross at the point 3 minus 1. If that also satisfies this, then it's on L3. So in L3, we get, and here we could set it up in different ways, so there's not just one layout, but whatever layout you choose has to be logical. So I'm going to do a slightly more formal one, which is that the left hand side equals 2 times 3 minus 5 times minus 1, which is 6 plus 5, which is 11, which equals then the right hand side. Therefore, M is on L3. Therefore, L1, L2, and L3 are concurrent. You can never have too many words. So, have a go at the odds in 5D.